Hey everybody, welcome to 12.3. Today we are moving on to geometric sequences and series. And our learning targets are to determine if a sequence is geometric, to find a formula for a geometric sequence, and to find its sum. Okay, so remember we talked about arithmetic is when you add or subtract a common difference. Geometric is when you multiply or divide the same number. Okay, and instead of calling it a difference, we call it the ratio, the common ratio. So if you divide a number by its previous term, you will get R, which would be that common multiple, that common ratio. All right, so instead of adding and subtracting, now we're just multiplying. Some people might call it dividing too, but multiplying by a fraction is just like dividing, so same thing. Okay, so number one, just showing like what does it mean to be geometric? How are you getting from term to term? And it looks like in this case we're multiplying by 3 every time. Do you guys agree? To get from one term to the next, the common ratio is multiplying by 3. So you would say that yes, this is geometric because there's that common ratio, that common multiple. Okay, number 2, show that it's geometric. Find the first term and the common ratio. Okay, so I think what I'm going to do here is just make a list. When n is 1, the first term is what? 3 times 4 to the 1 power. So isn't that 12? And now let's find a sub 2. 3 times 4 squared. So what's that, 48? Let's do one more. A sub 3. What's 3 times 4 to the 3rd power? That is 192. Okay, I think we can stop there. So these are our first 3 terms. How are you getting from term to term? And does everybody see that you're really just multiplying by 4 every time? So because there is a common ratio, multiplying by 4, then yes, this is geometric. So I'm going to put a check mark for the first part here. Now find the first term and the common ratio. Well, we already found the first term. So a sub 1 is 12. What would you guys say that R is? R is just whatever you're multiplying by, and there it is right there, 4. All right, that's all we need for that one. Okay, formula. And again, you will be given this formula on any test or quiz. A sub n is equal to a sub 1 times r to the n minus 1 power. So you're multiplying a sub 1 times r n minus 1 times to get the nth term. Okay, so here we go. Letter A. Find the nth term. Okay, so we need to find for a sub n. And we're not going to get an actual number answer, right? Because we don't know what n is. So let's just follow the formula. A sub 1 is 10. What's r? How do you get from term to term? What are we multiplying by? Sometimes it's a little hard to see. Let's see. I sometimes, if I get stuck, I like to find one that I can see kind of easy and then go from there. So like, what if this was over 1? It looks like in the bottom we're multiplying by 10 every time. Okay, so I think our r is going to have something with a 10 in the denominator, and it looks like on the tops we're multiplying by 9. Now you might say, okay, that looks good for these, but what about this one? Well, yeah, 10 times 9 tenths is actually just 9. And 9 times 9 tenths is 81 tenths. And 81 tenths times 9 is, okay, so I think we're good. R ends up being 9 tenths. And then to the n minus 1 power, there's nothing to do with that. That's your answer in terms of n. Okay, letter B. Find the 9th term. Well, now that we have our formula, if we want the 9th term, should we just plug in 9 for n? So a sub 9 is going to be 10 times 9 tenths times 9 to the 9 minus 1 power. So 10 times 9 tenths to the 9 minus 1 power. You end up getting 4 point, so I'm just going to put about 4.30 because I don't have any more room. Okay, and then C, find a recursive formula. So recursive formula is where you go back and you say, well, to find any term number, it's the ratio times the previous term. All right, so the recursive form would be a sub n equals r, which is 9 tenths, times the previous term, which is a sub n minus 1. And again, you're not going to get an answer because we don't know what n is. So that's all you can do for that one. Okay, flip it over. What about, just like arithmetic, we found the sum. Let's find the sum of geometric sequences. Okay, so the sum formula for a geometric sequence is this. Again, where a sub 1 is the first term, r is the common ratio, and n is the number of terms. Okay, so kind of pretty easy. You just have to find all the stuff and plug it in. All right, so find the sum. So we need a sub 1, we need r, and we need, well, we don't know what n is on this one, so we won't have an actual number answer. We'll just have it in terms of n. So yeah, let's just plug stuff in. A sub 1 is 1/2. And then I like to put a big parenthesis here. 1 minus r. Oh, we didn't find r. Okay, how do we find r? How do you get from term to term? What are we multiplying by? And hopefully you guys are saying 1/2. Well, I guess you could have seen that here too. You're just multiplying 1/2 every time. So r is going to be 1/2. So it's 1/2 to the n power over 1 minus 1/2. And we can clean this up a little bit. I mean, that is the answer, but if you clean it up, it's 1/2 times 1 minus 1/2 to the n power, but 1 minus 1/2 is just 1/2. And then 1/2 divided by 1/2 just cancels. So the simplified answer in the end is 1 minus 1/2 to the n power. And don't even think about subtracting these because this has an n with it. Okay. Next one. Use a graphing utility to find the sum of the first 15 terms of the sequence. Okay, so this one we actually have a finite number of terms, so we can plug it in the calculator to actually get the answer. Okay, so I'm going to use the same formula. It says find the sum of the first 15 terms. So again, we know that a sub 1 is 1/3. What is r? Well, aren't we just multiplying by 1/3 every time? Okay, so r is 1/3 also. And then we know n is 15, right? Because we have 15 terms. So yeah, we can just plug this in the calculator to find the sum. So again, the sum formula is a sub 1, which is 1/3, times 1 minus r So 1/3 to the 15th power all over 1 minus 1/3. And we are allowed to use a calculator for this one, so we don't have to do the messy algebra. All right, so let's make a fraction of 1/3 times, and then we have another fraction inside here, 1 minus, then we have another fraction here, 1/3 to the 15th power, and then in the denominator, just 1 minus the fraction 1/3. Just be careful when you type it in, you should be fine. So for that one, we get about 0.4999, and then you could keep going if you want, but I'm going to stop here because I'm out of room. Cool. That would be the sum. All right, last one, number 6. Find the 20th term of the geometric sequence. Okay, so we're not finding a sum here. We're finding a sub 20. Okay, so in the end, we want a sub 20. So, do you guys want to list what we know? A sub 1 is 2. It's geometric, so we should be able to find r. What's the common ratio? It looks like we're multiplying by 3 every time. Okay, so r is 3. What else do we know? We know n. If there's 20 terms, we know n is 20. Okay, so is there any formula that links these parts here? So here, I'll give you guys the formula sheet. How can we find a sub 20? Well, it's geometric, so maybe we can use this one, right? A sub n equals a sub 1 times r to the n minus 1 power. That should work. Okay, so a sub n is what's missing. So a sub 20 is missing. A sub 1 is 2. R is 3. And then n minus 1 would just be 19, right? 20 minus 1. I'll just put 19. Yeah, and then all you have to do is just solve that. So 2 times 3 to the 19th power. So that is a really big number. 2, 3, 2, 4, 5, 2, 2, 9, 3, 4. Let's get some commas in there. That is your answer. That's the 20th term. All right, thanks for watching, guys.